we're going to start a new tutorial. This one is going to be creating a character controller using the character controller component. So this is not going to be physics based. It won't be able to interact with physics and whatnot. All you're going to do is create a new project. Once this window loads up, we're going to be working in 3D, and you can just name it whatever. I'm just going to do character controller tutorial, and you'll just let up the entire project. So you're going to want to update your packages when you first start up a Unity project. So if you don't have Package Manager anywhere here, all you gotta do is go up here to Window, Package Manager, and it's right here. Now, for some reason, I'm getting a ton of errors, so I'm gonna go restart Unity. And there we go. So anything with a check mark means that it's already up to date. Anything with the arrow pointing up means that there's a newer version to update. And preview just means it's the preview version of it, so it's not like fully recommended to be used inside like big major projects and whatnot. But with TextMesh Pro, it starts off with the preview. You're just going to update. You're going to go through each one and update one after the other until they all have a check mark. Alright, so after you've updated all your packages, I'm just going to hit clear here. You're going to want to just go in and set up a zone where your player could walk around at. So I'm just going to right click into here, do 3D object, and just do a plane for now. So after you do that, we're going to go ahead and write up the script, and then we're going to set up the player and put the script all together. For organization's sake, I like to put my scripts inside of a specific folder called scripts. Or I know what some people likes to do is have specific objects made and then put the scripts for those specific objects made into there. But I like to just put all my scripts into one folder. So I create a scripts folder under the assets, and inside the scripts folder, I'm going to create a new C# script. And I'm going to go ahead and name this player movement. And then you're going to go ahead and want to double click and open. Alright, so your script. So when you first create a script, this is what it's going to first look like. So you have your usings up top, you have your public class, the name of the script, mono behavior, and then by default has the start and update functions. We're just going to go ahead and delete these at first, just so that they're out of the way, and we'll add them in if and when needed. I'm also going to remove the using system collections and system collections generic, just because we don't need it. Alright, so inside this player movement script, we're going to go ahead and assign all the variables first, and then we're going to actually write all the script that interacts with all those variables. So first, we're going to need to get a reference to our player controller. So we could either do this as a public character controller, which is the name of the component, and we're just going to call it controller. And we could assign this whatever character controller is inside of the inspector window of Unity, and we would drag the player in. Or we could go ahead and make this private, meaning that we won't have to do that, but we're going to have to assign it inside of the script, which is what I'm going to actually do. We're also going to create a bool. You don't have to if you don't put a public there, it'll automatically be private, or you could put private there. I like to just put private. I'm going to do a private bool, which is either a true or a false statement, is moving. And by default, it's off unless you tick it off. Next, we're going to create some float values. We're going to do a public float speed. And by default, we're going to make it like, I don't know, 10. We're going to do a public float gravity. And we're going to do something like a -9. And we're going to do a public float jump height. And we're going to do like 3 on average. So obviously the name of the variables, speed will hold 10, gravity will hold -9, and jump height will hold a 3. And we're going to use these numbers throughout the script. We don't even have to create variables. We could actually give these values inside of the actual script itself. But for organization and making it easy to read and know what exactly values are being used for what, it's better to put it as variables. And plus, since these are public, when I go ahead and save this and it compiles onto Unity, so let me just, don't do this, but if I just go and drag it onto the plane real quick, Now we could see that we have speed here, gravity, and jump height, and we could assign these values here, and it'll still take effect into the game. But we're not going to be putting it on the plane because that's not our player. Next, we're going to create 3 more variables. One is a public transform ground check. So I'm going to explain how we're going to do jumping once we actually get to the scripting part of that. Next, we're going to do a public float ground distance. And we're just going to do like 0.4 by default. And we're going to do a public layer mask. And we're going to do ground layer. And then 2 more variables. There's a vector 3 velocity. So we're going to be storing velocity in a vector 3. And this is, of course, private since we did not put public there. I like to put private there. This is a personal preference. You don't have to. And then we're going to do a bool is grounded. And that's also going to be kept private. Alright. So next, we're going to be doing a void update. So this is called every frame. This is going to be called every frame according to your computer's frame rate. Fixed update is what does it on the game's update frames. So what we're going to do is grounded is equal to physics dot check sphere ground check dot position ground distance and ground mask well layer. So what this is doing is that is grounded is equal to physics.checkSphere, which what this does is it will create like an invisible sphere, and if it collides with anything that has physics, so like colliders and whatnot, it'll do a function accordingly. It'll return that information back to be used further in the script. So the first one is position, which we're going to be creating a position for the sphere on our player. Next is ground distance. How large should the circle be in diameter? And then ground layer is the layer mask, which we're going to be assigning inside of Unity as well. Next, we're going to do if is grounded, and so these 2 and symbols, which you hold shift and press 7, means and velocity dot y is less than 0. Do a set of squiggly brackets. Then velocity dot y equal to negative 2f. Now, why are we doing this? We want it so that our player could snap onto the ground. So how we're going to be having this check sphere is that the sphere is going to be slightly lower than our player, so we could jump and whatnot. But we want our player to be attached to the ground. So if is grounded is true, meaning that the invisible circle is colliding with wherever we set the ground layer to, and our velocity is equal to 0, then we're just going to bring ourselves down all the way onto the platform by increasing our velocity and negative 2 on the y. Next, we're going to create 2 values. A float x is equal to input.get axis raw horizontal, and float y is equal to input.get axis raw vertical. Now, what does this mean? We're getting a float value. So if you don't know, float is a number that holds, I think, up to 16 numbers after the decimal, 16 digits. And we're creating a variable called x. And all we're doing is using the Unity's input. We're going to get the axis and the horizontal of it. So horizontal is the input inside of Unity's built-in input system. By default, it's set to A and D, A being -1 and D being +1. So if you go into Unity, you go to Edit, Project Settings, you could go down and find input manager axes, and you can see right here horizontal is left and right, which is also left arrow, right arrow. Alternatives are A and D. And same thing goes for vertical. If you go down to vertical, up, down is down arrow, up arrow, or the S key and W key. And it'll either be a 1, a -1, or 0, depending on which one you're pressing. So going back into the script. Next, we're going to do a vector 3 move equal to transform dot right times x plus transform dot forward times z. No, not reverb z. And I accidentally made a mistake, make the z. What this is basically doing, vector 3 is x, y, and z. And we're going to be moving our character. Transform dot right is whatever the right facing direction of our player is. It basically makes it easier so that if we're creating a script, we don't have to like explain what is to the right of our player. It already has the function here for us. So the right side of our player times x, which we said was a and d, a being -1 and d being +1, plus transform dot forward times z, meaning forward, going forward, and vertical keys are W and S, so W being 1 and S being -1. So basically what this is doing is, if we press any of the horizontal keys, so for example D, it's going to transform.right times 1. Now if we go down one more, we're going to do controller dot move. This is what's actually going to move the player. So we're going to do move times speed times time dot delta time. And I did time up. Make sure you don't have any typos. If you have a red squiggly line underneath of anything, that means that there's an error there. So what is this doing? Taking the move variable that we created, which was the transform right times x plus transform dot forward times z. X is here, z is here. And controller is how we basically call the character controller component. And move is a function within the character controller component that we use to actually move the player. And so we're doing move, so forward, backward, left, and right, times speed. So wherever we have our speed set to, which up here is 10, times time dot delta time. All right. So the difference between time dot time and time dot delta time is that time dot time is the seconds since the application's been started, and time dot delta time is the time since the engine processed the previous frame. So it's basically doing all of this under the engine's frame rate versus your computer's frame rate. Therefore, it's going to make your character move at a constant speed on any system, no matter the frame rate the system's actually getting. It's only based on the engine. Now, if we were to save this and apply everything to the character now, we would be able to move. But we still need to get the jump added in. Which actually, it's not that hard. It's only like 10 lines, I think. So, we're going to do a if input that get button down jump. And the two and symbols is grounded. If is grounded is true. If we wanted to be if is grounded is false, we would do exclamation mark meaning not, the opposite of it. But we want if is grounded is true, so we could jump only if we're on the ground. Do the squiggly brackets, and then velocity dot y is equal to math f dot sqrt or squared jump height times -2f times gravity. Now this is basically doing a math equation inside of it. It's going to do the squared value of jump height times -2 times gravity. Now why are we doing a -2? It's because gravity is a negative. If we kept this positive, we would actually be jumping down rather than up, and that just doesn't even make sense. So if we have jump height as a positive value, -2, which we're going to be doubling so that we could actually jump higher than the gravity, since it's going to be pulling us down, times gravity, and gravity is a negative number, so it would actually make this entire equation positive and make you jump up, and it's going to square all that. So then you could jump, gradually lose momentum jumping up, and then it would. Next, we're going to do a velocity dot y, and we're going to increment gravity times time dot delta time. And this is what I mean by gravity will gradually pull you down faster and faster, because it's being done by the engine's time frame since the last time the frame was called. And then we're just going to apply this gravity to the character controller. So we're going to do controller dot move velocity times time dot delta time. And there we go. This is the entire movement script. So if we were to save this, go back into Unity and let this compile. All right. So go into scene view, and we're gonna go ahead and create the player real quick. So we're going to do. You could do either a capsule cylinder. I prefer a capsule. I'm just going to reset it. I'm going to go in and rename this player. You could either right click and do rename, or you could click on it, press F2, and then rename it that way. I'm going to position them slightly up higher. I want them to be slightly taller, so I'm going to do like a 1.6. That's fine. We're also going to put the main camera inside of the player. And I'm also going to go ahead and reset. So now the camera is inside the player. And I'm also going to go in and adjust this a bit up to what I think is about eye level. There we go. So now we're going to go ahead and attach this player movement script to the player object. I also forgot that since we made character controller private, we're actually going to have to assign what character controller is. So we're going to do void. We're going to do void start. So when the first frame of the scene is called, we're going to do controller equal to gets component. You're going to do these arrow keys, character controller, close parentheses, and a semicolon. There we go. So anywhere in the script that controller is called, it's basically just get component character controller. So we're getting the character controller that the script is attached to. And so if you go to add component, physics, and character controller, now we have the character controller. And there's some stuff here, so slope off, slope limit, step off, and then there's skin width, mid move distance, and all that, height, radius, all that. All right, next script we're going to be doing is a C# script. And this is going to be the camera movement. And you're going to go in and create that as a new script and open it inside of Visual Studio. And here we are. So next thing we're going to do, we're actually going to be using the start and update function, so I'll keep them here this time. Generally, I like to remove them, and we don't need those other stuff up top. So we're going to be creating some variables. First one is a public float mouse sensitivity. I had to say that out to spell it. And we're also going to do a public transform player body. And we're also going to do a float x rotation equal to 0f. So I'll be explaining what some of this stuff is going to be doing when we get to it. So at the start, we do not want our cursor to show. So we're going to do cursor lock state equal to cursor lock mode locked. So this will lock our cursor into the center of the screen so that we can't like move it off to another window and click off the game. And then we're also going to do a cursor dots visible equal to false. So our cursor will be invisible and locked to the center of the screen. Next, we're going to be doing everything else in the update function. We're going to do a float mouse x equal to input dot get axis raw. If we don't do raw, then it won't feel smooth like turning the camera around. We're going to do mouse x, which I've shown before is inside of the project settings. Yeah, no, never mind. It is in project settings. Input manager, and if I go in and bring this down, mouse X and mouse Y is here. That's what we're going to be using. Mouse X, and then we're going to be timing that by mouse sensitivity. So based on how high the value is how sensitive the mouse is going to be. And then we're going to do the same thing, but mouse Y. All right, next, we're going to do X rotation, negative, if I could type that right, negative equal mouse Y. And then we're going to do X rotation equal to math F dot clamp. X rotation negative 90F, 90F. So what this is going to be doing is keeping us from basically turning our heads up and down infinitely. So we only can look down to the ground 90 degrees and up into the sky 90 degrees. And we're doing this as X rotation because if you rotate something in Unity along the X-axis, I need to open up Blender. If you rotate something along the X-axis, so I go and do this camera, and I rotate it along the X-axis, you can see it's looking up and looking down. And then finally, we're going to be rotating our player as we turn. So if I do transform, not capital T, transform local rotation equal to quaternion dot Euler, and then X rotation 0F 0F. So all we're going to be doing is turning our player left and right, but not up and down. So we can't, like, if we look up, our player won't be completely horizontal. And then we're actually going to go ahead and rotate the body of the player. Rotate vector 3 dot up times mouse X. So in Unity, vector 3 is straight up, so it's basically referring to the y-axis. And if we rotate something along the y-axis, which I'm going to demonstrate with the camera here, it turns left and right. So it's only going to be turning us on the y-axis so that we could actually turn left and right, but it won't turn us up on the x-axis, which would be up and down. So we won't be like flipping and completely horizontal, looking straight up or straight down. And this is going to be it. So if we go ahead back into Unity and let this compile, there we go. We're going to go ahead and build up the player. So you're going to put the camera movement on the main camera itself. So player body is going to be this player, the actual player itself with the player movement script and the character controller. And inside the player movement script on the player, we're going to go ahead and create a. So after you assign the player body, we're going to actually have to create a layer real quick and call this layer ground. And then click onto your plane. Inside the inspector window, click onto layer. It's going to be by default, and do ground. And inside the player, we're going to scroll down to the player movement script component. And where it says nothing for ground layer, switch that to ground. So what we're doing is that since now that plane is ground inside the player movement script, we had it so that if we are grounded on the ground, we could jump. And ground is only detecting if it's colliding with something on the ground layer, which we have assigned as ground here. Next, we're going to do a ground check. And how we're going to do this is we're actually going to go ahead and create a empty game object. And you could just name this ground check or whatever you want. Make this a child of the player. And you're going to want to position it. I'm actually going to make this 0, 0, 0 on the position. Now, what you're going to want to do is position this near the bottom, but not the very bottom, or else the player will be able to jump again without even actually touching the ground. That's good. So now, go into the player, go down the player movement component, and drag ground check into there. So now, if we go in and press play and try testing all this, so I just realized that mouse sensitivity was super high. So we'll just set it down to like 5 or something. And let's try this again. And here we are. So I could turn left and right, up and down. I can move around. I could jump. And if I were to go ahead and make a slope real quick, I could walk up on it, jump, whatever. I could jump off, and it works just fine. And that's how you make a simple character controller, player movement, whatever you want to call it. This is my first tutorial, and this is something different from what I usually upload. I'm still going to upload like other stuff that I usually do. Hopefully this was helpful. If you have any suggestions of other stuff, I have a huge sandbox project that I've been working on. If you want to know how I did anything in there, I would not mind doing a tutorial of it. Hopefully this all helps, and thank you for watching.